Okay, the next problem on our study guide is an object weighs 3.8 times 10 to the negative 3 kilograms. Express the weight of something 100 times heavier using scientific notation. Alright, that's a little ambitious with a negative exponent, so what I'm going to do is give you that same example using a positive exponent. So I rewrote it out here using a positive exponent, and then we need it to be 100 times heavier than that. Alright, so can I just take this and multiply it by 100? Would that work? Well, absolutely it would work. But what's another way we can make something 100 times bigger? Well, could I multiply it instead of by 100? Could I multiply it by 10 to the second power? If I multiply something by 10 to the second power, 10 to the second power is 100. I'm multiplying this by 100. So I'm making this 100 times heavier. Just like here, I'm making this 100 times heavier. Well, wait a minute. If I do this, 10 to the third looks like this, and 10 squared looks like this. Isn't that just taking this and multiplying it times 10 to the fifth power? Well, it is. It is. So I basically took this number here, and by raising the exponent 2 times, I made this number 100 times bigger. Check it out. If I take 3.8, this original number, times 10 to the third, and write it out in standard notation, I would write 3.8, and I would move the decimal 1, 2, 3 spaces to the right. Okay, this number is 3,800. If I multiplied that number times 100, I'll let you do the multiplication, but I happen to know that it would be 380,000. So this number is equal to 3,800. If I make it 100 times bigger, it equals 380,000. Well, what is this number equal to? Move it 5 places to the right. Wait, this is also 380,000. So when I make this number in standard notation, I get 3,800. When I make this number 100 times heavier, it equals 380,000. Well, and when I made it 100 times heavier just by raising the exponent 2 places, it became also 380,000. So let me give you another example. If I have 5.3 times 10 to the first power, and I want to make it 10 times larger, well, if I make this 10 to the second power, I just made this number 10 times larger, because the way it's written now, if I move this 1 space to the right, it becomes 53. But if I move it 2 spaces to the right, multiplying it by 10 squared, it becomes, move it 2 spaces to the right, it becomes 530. 530 is 10 times more than 53. And I express that by just increasing my exponent 1 power. So here was our original problem. it was 3.8 times 10 to the negative 3 power, and we want to make it 100 times bigger. Let's look at what this number is. 3.8, if I move my decimal 3 spaces to the left, becomes 38 10,000ths. Tiny little number, 38 10,000ths. Now, if I make this 100 times bigger, all I have to do is move the decimal 2 spaces to the right, and it becomes 0.38. So if I make this 100 times bigger, it becomes the number 0.38. The way I made it 100 times bigger was I wrote this out in standard notation, and then I moved the decimal 2 places to the right, and I made my number 100 times bigger. Now if I write this number in scientific notation, it equals 3.8 times 10 to the negative 1 power. So this number is 100 times bigger than this number. Well, how is that possible? Didn't we say that if something's 100 times bigger, that means we increased it by 10 to the second power? Well, if I increase negative 3 2 times, if this is 10 to the negative 3, and this is 10 to the negative 2, and this is 10 to the negative 1, and this is 10 to the 0, and this is 10 to the 1, and this is 10 squared. This is 1, this is 10, this is 100, this is 1/10, this is 1/100th, and this is 1/1000th. That's how base 10 works. Going this way, to the right, things are getting 10 times bigger. Going to the left, they're getting 10 times smaller. So if this is 10 to the negative 3, and I increase it by 2 exponents, I would increase it to 10 to the negative 1st, which is exactly what we did. So from here to here, we raised it 2 positive exponents. From here, 1, 2, to here, we raised it 2 exponents. We made it 100 times bigger.